Decades of wreck-derived salt aerosols create persistent coastal fog that suppresses photosynthesis, producing barren strips where dunes meet the Atlantic. The skeleton coast stretches for roughly 500 kilometers from the Ugab River to the Canine 3. It is one of the most desolate and dangerous shorelines on Earth, but it is not dangerous because of sharks or storms alone. The real threat is invisible, silent, and persistent. It is the fog. The fog here is so thick and so frequent that it has turned this stretch of desert into a ship's graveyard with over 1,000 recorded wrecks 1-3. And here is the twist that most people miss. Those very wrecks might be making the fog worse. It is a feedback loop of rust and ruin. The more ships sink, the denser the fog becomes, and the more ships sink in return. To understand this, we first have to understand the fog itself. The skeleton coast sits at a brutal collision point. The cold Bangla current flows northward along the coast, bringing frigid water from the Antarctic 147. This cold water meets the blistering heat of the Namib Desert, one of the oldest and driest deserts on the planet, 112. The interaction between these two extremes creates a giant natural air conditioner. Warm, moisture-laden air from the Atlantic is forced to rise and cool over the cold Bangla waters 10. The moisture condenses into tiny droplets, creating a low-stratus cloud deck that can stretch for hundreds of kilometers. This is the main ingredient for the coast's famous fog 128. But condensation is only half the story. Fog also needs a reason to stay. Along the skeleton coast, the air is trapped. A permanent high-pressure system, the subtropical high, sits over the region. This system pushes air downwards, creating a strong temperature inversion 128. Imagine a lid placed over the atmosphere. The cold ocean air sits at the bottom, while the warm, dry desert air sits above it. Because warm air is lighter, it acts like a ceiling, preventing the cooler, foggy air from rising and dissipating 110-11. The fog is effectively locked in place, hugging the coast and the first few hundred meters inland 28. This inversion can last for days at a time, reducing visibility to near 013. The persistence of this fog has made the skeleton coast a legendary hazard. Before radar and GPS, captains were sailing blind. The thick fog, combined with strong southerly winds and powerful currents, would push ships dangerously close to the shore 179. And that shore is full of hidden dangers. The coast is littered with shifting sandbars, reefs, and rocks that are poorly charted 3-5. One moment, the sea seems clear. The next moment, you are scraping against a reef that is barely visible just below the surface. The combination of these factors has created a perfect storm of shipwrecks, turning the coast into a graveyard of rusted hulls 5-7. One of the most famous victims is the Eduard Bolin, a massive cargo ship that ran aground on September 5, 1909, in thick fog 39. The 310-foot-long vessel was carrying steam boilers when it wrecked at Conception Bay. Today, it lies 400 meters from the shoreline, slowly being swallowed by the Sand 9. The shifting coastline has pushed the ship further inland, making it look like a ghost ship stranded in the middle of the desert. It is a powerful symbol of the coast's power. The ship is no longer in the water, but the desert is now consuming it. The rusting hull has become a permanent part of the landscape, a monument to the fog that put it there 3-9. Another dramatic disaster occurred in November 1942. The British liner MV Dunedin Star struck a reef while carrying passengers and cargo 3. The ship broke up, stranding 43 people aboard the wreck and forcing 63 others to reach the desolate beach with almost no supplies. The survivors had escaped the sea, but they were now trapped on a desert that offered no food, no shelter, and no fresh water. Rescuers had to be parachuted in to help them. It took weeks to rescue everyone. The story of the Dunedin Star shows that the skeleton coast is a trap that closes from both sides. The ocean kills you with waves, the desert kills you with thirst, and the fog makes sure you never see either one coming. The name itself comes from the bones. The coast is called Skeleton Coast because of the countless whale and seal bones that were left behind by 19th and early 20th century whaling operations 1-7. Hunters would strip the blubber and leave the carcasses to rot. The skeletons of these animals, along with the rib cages of ships, were scattered across the beach like a boneyard. The San people, the indigenous inhabitants of the region, called it the land God made in anger 7. Portuguese sailors called it the gates of hell 7. They knew the coast was not just empty, it was actively hostile. It was designed to trap the unwary. But what about the iron-rich aerosol theory? The idea is that rusting shipwrecks release iron oxide particles into the air. Iron is a limiting nutrient for phytoplankton in the ocean. But in the air, these microscopic particles act as cloud condensation nuclei 26. That simply means they give water vapor a surface to condense onto. More particles mean more droplets, which means thicker, denser fog that lasts longer. It is a self-perpetuating cycle. The fog causes ships to wreck, the wrecks release iron particles, and the iron particles make the fog thicker. This is a form of positive feedback that locks the coast into a state of perpetual mist and danger 2-3. Let's break down the mechanism more carefully. As the iron-rich particles are released from the rusting hulls, they float upwards and mix with the moist ocean air. The particles are hydrophilic, meaning they attract water. In the saturated air of the skeleton coast, they act as tiny seeds around which water molecules accumulate. A fog droplet forms. In a clean environment, you might have a small number of large droplets. But with a high concentration of particles, you get a massive number of very small droplets. These small droplets scatter light much more efficiently, making the fog appear thicker and whiter. It reduces visibility even further. It is a physical change to the local atmosphere driven by human-made debris 26. This increased fog density has a profound effect on the nearby ecosystem. The fog is already the primary source of water for the Namib Desert, even more important than rain. The coastal fog that is trapped by the inversion layer provides up to 180 millimeters of moisture per year, while rain often averages less than 50 millimeters to 5. This is a critical water source that supports the region's unique biodiversity. Fog provides life to everything from the beetles that drink from its droplets to the lichens that absorb its moisture, and the plants that are able to grow at all 212. The iron feedback is not just about shipwrecks. It is about the very survival of life in this hyper-arid environment 1-5. The thick fog also creates a unique ecosystem. The fog is so consistent that certain species have evolved entirely around it. The head-standing beetle, for example, creeps to the top of a sand dune when fog is present and faces into the wind. It tilts its body forward so that the fog precipitates on its back and runs down into its mouth 12. This is a life support system. Without the fog, the desert would be almost completely barren. The fog supports insects, which support lizards and birds, which support larger predators. It is a food chain built on mist, and the shipwrecks may be playing an unknowing role in sustaining that chain by feeding the fog 1-2. This region is a thermal and chemical isolation cell. The cold Bengla current, the heat of the desert, and the high-pressure inversion create a boundary that traps the fog and holds it against the land. The wrecks are artifacts of that boundary. The rust from the ships is now part of the boundary's chemistry. It helps maintain the fog. It helps maintain the isolation. The desert has a strange way of absorbing anything that enters it and making it part of its own machinery. The ships are no longer ships. They are part of the fog machine 1-4. This region is Earth's render boundary. Next discovery, the diamond mines that disappeared into the sand.